Welcome to the course E8351 Digital Logic Circuits. Okay, so here we'll be seeing about what is meant by flip-flops, SR flip-flop, one of the flip-flop, and how to trigger those flip-flops. Okay, triggering of flip-flops. So the course outcome is at the end of this section one can able to understand the operation of various synchronous sequential circuits. So here the flip-flops, it is nothing but a memory element. So here we have many different types of flip-flops: SR flip-flop, JK flip-flop, D flip-flop, and toggle flip-flop. Okay, so SR flip-flop is also called as set reset flip-flop, and JK flip-flop is same as the SR flip-flop. J is timed as set, and K means it will be reset, and D means it will be the toggle flip-flop. So here latches are controlled by enable signal, and they are level triggered. Okay, so by giving some input pulses we can able to turn on or turn off the uh, flip-flops. Okay, so here latches are controlled by enable signal, and they are level triggered, either positive level triggered or negative level triggered. So output is free to change according to the S and R input values when active level is maintained at the enable input. So flip-flops are different from latches. Flip-flops are pulse or clock edge triggered instead of level triggered. Okay, so here different types of level triggered pulses are shown: positive level triggered, then negative level triggered, then pulse triggering, positive pulse, negative pulse, then edge triggering, positive edge triggering, and negative edge triggering. So here the next one is the SR flip-flop. So here we will be dealing with any one of the flip-flop. I have taken SR flip-flop for the operation. Okay. So here the SR flip-flop, S and R will be the input. S it represents the set, and R represent the reset. Reset flip-flop. Okay, so are called as this flip-flop is the synchronous flip-flop. SNR flip-flop are called synchronous inputs because data on these inputs are transferred to the flip-flop's output only on the triggering edge of the clock pulse. The circuit is similar to SR latch, except enable signal is replaced by clock pulse on the positive edge of the clock pulse. The circuit responds to the S and R inputs. So this is the general logic diagram of SR flip-flop, and logic symbol of SR flip-flop is shown. So this is the truth table of the SR flip-flop. Okay, so here when the S and R both inputs are 0, it has no change state. When S and R in both inputs are 0 and 1, it will be in the flip-flop will be reset. If the S and R 1 0, so then the flip-flop will be set. If both the inputs are 1, then that state will be indeterminate or no change state. We can call it as no change state. Okay, that's all about the SR flip-flop. Thank you.